Astronomers have so far detected more than 2,000 planets outside our solar system. Many of these exoplanets are only discovered from the changes in brightness they make to their host star. But now, Russian scientists say they have a technique for creating a telescope that can see these planets directly, and they say it may even help us find Earth's twin. The research has been led by Alexander Tavrov, an associate professor at the Moscow Institute of Physics and Technology. Tavrov's paper explores something known as a EUI, or extremely unbalanced interferometer. Interferometers because they work by merging two or more sources of light to create an interference pattern, which can be measured and studied. In astronomy, an interferometer is usually made up of an array of telescopes or mirror segments that act together to probe structures with higher resolution. Conventional interferometry looks at light waves with equal intensity so that they can be combined into a single wavefront to produce a clear and sharp image. The difference with the EUI is that light is divided into two beams, weak and strong. A weak beam passes through the adaptive optic system, after which the two beams are brought together again and interfere with each other. As a result, the weak beam smooths out the light of the strong beam. Tavrov says this can significantly reduce both the distortion of the wavefront and the contribution of stellar speckle patterns, or a random interference pattern. Through the use of a relatively simple optical setup, we can obtain the image contrast at the quality necessary for the direct observation of Earth-type planets, said Tavrov. Of course, compared to foreign developments, our system requires a more complex control technique. But at the same time it is much less dependent on the temperature stability that greatly simplifies its operation in space. In the future, scientists plan to create a laboratory prototype and perform a number of experiments on it. As Tavrov notes, we want to see the distant world through a telescope, but it implies that the distant world might see us as well. An advanced technology, by only some 50 to 100 years, could be enough to do it many times more precisely than we are able to do it now.